Hello and welcome to this RedMonk Conversation. My name is Kate Holterhoff, Senior Analyst at RedMonk, and with me today is Derek Collison, Founder and CEO at Synadia and creator of NATS. Your friends call you the Forrest Gump of messaging, so I can't wait to hear more about that moniker. Derek, thanks so much for joining me on the Monkcast.
Kate, thanks for having me. I appreciate it.
All right, so I'm excited to have Derek chat with me as part of my ongoing research into the history and future of messaging. And historically, I've been talking a lot about message queues here. Of course, today we're going to be talking a lot about NATS and TIBCO and all these sort of things that Derek's history has touched on. But before we get into your career history, Derek, I want to kick off this conversation by addressing why this topic still matters so much. So at a high level, how do you define messaging? And when you talk to folks today, in 2025, how do you explain its importance in our era of distributed systems?
That's a great question. I think in the 90s when I joined a company called Technicron, right, which became TIBCO, the CEO had a very clear vision and understanding of what was about to happen in financial trading systems, right? We were moving from humans doing everything to programmatic trading. And for the most part, information distribution was done, to his point, I'm using his metaphors here, like a phone call, right? And so if I called you first and then I called, four other people, humans, our brains switch at about 160, 200 milliseconds or so, right? That's the golden rule inside of Google is it has to get back outside. The response has to go back out less than 200 milliseconds based on that. However, once programmatic trading was going to come into effect, that last person was at a major disadvantage. Vivek's, who is the CEO of Technicron and then TIBCO, his vision was simply to change telephone calls into a radio station that you could tune into. And that was kind of the birth of kind of the initial pub sub type stuff. When you talk about modern systems, I think pub sub is kind of a dated term, right? However, I do believe deeply in what I call intelligent connectivity. So when I started my career, I got very lucky, but I was not feeling that way when it happened, which is I graduated university out of Maryland and went to work for a program at the Applied Physics Lab. And I got selected by the second best physicist at the lab. And what that simply means to the audience is that I had orders of magnitude less time on the supercomputer. This was an age of everything was vertically scaling, right? In the late 80s. I mean, I did university courses in concurrent programming, but I'm like, this is kind of goofy. No one's ever really going to do that. And so the physicists kind of looked at me and they said, hey, we've got these 12 Spark pizza boxes down in the basement, right, of the lab. Can't you make them do what the Cray does or the connection machine does? And these were incredibly brilliant physicists and mathematicians. And I just kind of looked at them. I'm like, no, you can't do that. Fast forward to today, everything is scaled horizontally. Everything is a distributed system. And I think what we've seen with kind of this massive transition, in my opinion, from cloud to edge is that not only are the systems continuing to grow in complexity, the number of moving parts, but they're being pulled apart, right? And so a lot of times you're not trying to vertically scale something, you're just simply trying to get it closer to wherever it's being consumed, whether it's a service or data, right? And so you could say, wow, I have the fastest computer in the world, but it's in Europe. And let's say I'm on the East Coast, you might be on the West Coast, you're in Europe, wherever. It's more of a latency thing, right? So these systems are getting spread apart. And so when folks ask me about like Synadia's tech or NATS, especially in terms of the connectivity piece, I say there's a couple superpowers that NATS has, in my opinion. One is location independence. Everything we do, all distributed systems are based on location dependent. I need to know where you are, right? And of course, people can argue in the audience and say, no, that's not true. We've got, blah, blah, blah. But I would counter with that you're doing unnatural acts to get that. So in other words, when you do HTTP, you go through DNS, there's DNS tricks, right, with Anycast. Then you go to GSLBs, right, these global load balancers. Then you go to load balancers. I mean, there's so many things going on to get away from the fact that the base construct of distributed systems that have been built with legacy tech is everything is one-to-one, everything is request reply, and everything is synchronous. And anytime it's not, you're doing unnatural acts. So you've got more moving pieces that either cloud providers provide, XYZ. And so even though I don't say pub sub very much anymore, this notion of location independence, if you're listening on a certain, I call them subjects because that's what we called them at Technicron and TIBCO, but topics, channels, whatever those are, it doesn't matter to me where you are. Moreover, it doesn't matter if there's one Kate or there's 1,000. I just need to know I'm talking to a Kate, and I need to know that it's the best one, which is usually a latency sensitivity thing, meaning pick me the closest one. And so what Nats tried to do from all of the lessons learned from Technicron and TIBCO with TIBCO's Rendezvous, which I was a co-founder of that group behind the what was called the CI server. Then I architected the modern version of Rendezvous, and then I went to create EMS, which was the enterprise messaging system. We worked with Sun and others creating the JMS spec and then the WS star stuff, which was kind of a debacle. And so Nats kind of was bred out of all of that learnings and frustrations. And I call them scars on my back. It's not an IQ thing, it's just a number of scars. But the fact that it's location independent by default, it's M to N by default. M to N is kind of like the audience might say, what do you mean? HTTP is one-to-one. I know I'm talking to a single instance. I resolve an IP address. And again, if that's not happening, there's unnatural acts going on with load balancers and tricks to undo that. Nats has that natively, and everything is end-to-end, meaning me as one can be talking to N Kate, but I only want an answer from one of them and the best one. So now you start to see that there's no need for load balancers or GSLBs or even DNS, right? And I still have a t-shirt somewhere that says always blame DNS. The other thing that Nats did, which now makes a lot of sense, but back when we were doing TIBCO, people were like, what? The protocol itself is always async. HTTP started synchronous, and of course they've added asynchronous behaviors into it now with HTML or HTTP 3 and quick and stuff, and then multiple async streams going on in the same physical connection. You're starting to see that. And so for me, those two things are probably the most important part. And then the second part, which again goes from if you believe that these distributed systems are gaining complexity, more moving pieces being stretched apart, XYZ, you can start to see why location independence and M2N as the default makes sense. The corollary, though, that needs to happen is that these servers are not like a broker, right? They're extremely lightweight. I don't know if it's relevant anymore. I'm dating myself, but they're more like cattle, not pets, right? And you can Lego brick these things into any topology that can cross cloud providers, cross geo boundaries, all the way out to edge. And for us, we call it near, far, and beyond. Near is, and this might be controversial, but near is the cloud providers trying to say, ooh, we do that too. I really think they're the new mainframe, meaning they're not going anywhere, but the interaction models are already starting to shift. Far is kind of the traditional and some of the newer entries into Edge. So the Akamai, Cloudflares, Fastly's of the world, but also the Vercells, Dino Deploy, Netlify, and I think they will have their unifying event, kind of like Kubernetes did for cloud. But where we start to really shine is what we call far edge, which is your factory, your store, your electric vehicle, your connected car, your satellite, your train, your medical device, your toothbrush. All of that stuff are areas where Nats already runs and powers those types of interactions. The last thing, and then I'll pause because I know I've been talking a little bit, is that when we talk to customers, I'm not trying to change the what. So, like, let's say you and I want to design a new system. We would be drawing the same blocks and circles and microservices and key values and RDBs and XYZ. I think what Nats and the Synadia technology platform does is it just radically changes the how, right? So we're still doing, hey, I need to invoke this microservice, right? But let's say I'm inside of a vehicle, an electric vehicle. I don't know where that microservice is running, and I shouldn't care where it's running. And I don't care how many of them are running. They could be running in the vehicle, they could be running on the cell towers, they could be running in geo cloud pinning, doesn't matter. And in our world, there is no additional cognitive load. Batteries are included. And so let's say the requester is the Kate app, right, running in the vehicle. It's simply asking the question, and all of a sudden it just gets a very, very fast answer because it's running literally right next to you on the same ECU. So hopefully that makes a little sense. Location independent, end-to-end as the default, and then these servers as very lightweight constructs that you can Lego brick together to form any type of topology that you need.
Yeah, that's great. And you're right. There's a lot jammed in there. So I'm hoping we can kind of take a step back and parse some of the stuff that you've been mentioning here. So, and also I was interested when you mentioned the asynchronous quality, because I think one of my biggest takeaways from talking to folks like Andy Stanford Clark is that it's the creating these asynchronous connections that was really sort of the end goal. That's really where the innovation happened decades ago, right? Especially in the financial industry and in the airlines industry as well. So so that all of that's really resonating with some of the conversations I've been having around this subject, and I appreciate you building on that and helping me to flesh out that story. So you mentioned the physics lab, and so you, just for folks who aren't familiar, this is the Johns Hopkins Applied Physics Lab, which I only know because I've been stalking you on your LinkedIn account, and you have a, of course, a really exciting list of companies that you've been affiliated with, projects that you've worked on, and so I was super interested in that. And I was curious if you had gone to school there in some capacity. How did you end up at the physics lab, and like what did you study in college to end up there?
Yeah, so I studied computer science in university. I graduated from Maryland in 1990. Yeah, I think so. That's correct. But I had summer internships, and since I was in Maryland, Washington, D.C. was a big hotbed, and the applied physics lab, I knew some people there that knew of me and liked me enough to kind of recruit me before I graduated to join. And they had a program inside of the APL around an organization that at the time wasn't known publicly called the NRO, and so did some interesting work on some very, very cool projects there for them.
Yeah. Did you like working in an academic setting? I mean, I can see that I used to be an academic for a decade, so I know the sort of ins and outs of what that is like. And what was your sort of impression of working with academics?
Well, I mean, it's capital A applied physics lab.
Okay,
So the physicists and the engineers like myself were rewarded on delivering things, not necessarily papers.
amazing.
Now
Yeah,
we did do a bunch of research, but it was always in support of a project, right? And so we had a very specific project that we were all working on. And so everything that I was working on with the multiple physicists and the software and the engineering was all in support of that project, which was a very high priority for that organization at the time. Still is, but I mean, back then it was a very big deal. Um, so it was very exciting. I like the applied part of it
okay.
versus the pure academic part of it.
Sure.
For sure, I like to people who know me say GSD, get stuff done, but stuff may be said differently type stuff.
Hmm.
But no, it was a massive laboratory of results versus the academic. Now, Johns Hopkins, of course, has more of the academic flavor, and being tied to them is just awesome, right? But I think we only did a couple papers, and they were, if I recall correctly, yeah, those never saw the light of day because they were top secret, so couldn't show what we came up with.
How
I think that you
exciting.
can now. I think that was declassified a while back.
Okay. Fair enough. All right. So that's your sort of academic background. Can we go further back in time? Like, were you part of like a robotics team in high school, or like what was, how long were you interested in computers? You obviously majored in it.
Yeah, so I think I was born at just an amazing time, right? And I got extremely lucky. We grew up never wanting anything, but we were not well off. But again, I had an amazing childhood. But I had a friend who in middle school got a Trash 80. And I was like, what's this thing? And so I would just be at his house every day and trying to figure out how to do this. And for Christmas, I think that year, my little grandma, my maternal grandmother, or we called her little grandma, she just said, I'm going to get him a computer. My parents were like, we can't afford that. And she's like, I'm getting one. So she got me a Commodore 64, and then she got my sister one. And my sister could care less about computers, right? And so I stole hers for parts after a while. But that was the land of, there was no robotics classes. There was nobody even knew what a computer was. We barely had to use the TI calculators, but I loved it. There was no manuals really, so I just stay up all night. I was connected to a cathode ray, black and white little TV that was about 11 inches big. I would cover my head up at night so that my mom didn't know I was staying up, all night on it. And so I originally thought I wanted to be a doctor, and that probably just wasn't going to be able to happen. And again, life can be very interesting that way because it was a blessing in disguise. So when I actually finally did move to California, one of the first jobs I had was with a healthcare startup. And again, I got thrown into distributed systems again. So I'm a little slow sometimes, but eventually, it kept hitting me on the head of maybe this is what I was supposed to be doing. But for whatever reason, the startup paired with a company out of Carlsbad, California, called Puritan Bennett. They don't exist anymore, but they were in the medical devices field, and they had created the first intra-arterial blood gas device. And for whatever reason, they thought it was a good idea to let this 22-year-old at the time run all the federal trials for it. So I did all the data collection out of Stanford Hospital, and I had to do a bunch of surgical cases. So I think the two cardiothoracic, two neuro, two GIs. I had to do two morbidity cases, if I recall correctly. So much time in the SICU, NICU, all that stuff. So I got my fill of it, and it was exciting, but also very depressing for me. And I just realized at that point how lucky I got. Because even to this day, I'm getting up there. I'm 56 now. I'm still amazed by how fast technology is moving. I studied neural networks in university because it had just kind of been invented, right? In 80, the back prop stuff, right? In 86, 87, I think. And then we hit the largest AI winter, right? So I've been following it even though, it didn't go anywhere. And about 2.5, 3 years ago, when ChatGPT 2 came out, I was like, uh-oh. And so all the people around me started going, he's geeking out. I'm like, I'm telling you that this time it's going to stick, right? We're going to get there this time. And everyone kind of laughed at me, but I think they kind of see the path now, right? That it's definitely something very, very different than what's happened in the past. But I got extremely lucky. And the fact that edge computing and distributed systems and the way these things connect and communicate, move data around is still so relevant. I'm extremely grateful that I got lucky. But yeah, I'm trying to keep up like everyone else on the advancements in AI. And I mean, it's just bonkers to me, but it's exciting. I'd rather lean in than lean back, if that makes sense.
Yeah, for sure. I know there's so much cool stuff coming out in the news every day. It seems like I'm a big podcast buff, obviously, and so I tend to keep up in that respect. And yeah, no, it's truly a
So
wonderful
you
time to
probably
be
love
following.
the Notebook LLM. I think it took me one time playing with it and doing the auto generate the podcast to realize that's how I
Yeah,
do all my first step research now. I just load the PDFs,
really.
load the YouTube videos, and say generate a podcast. I then download on my phone and go for a run or a walk, and that's how
Yeah,
I first absorb stuff. But I mean, the other thing, and you know this, but our brains are about 50,000-year-old wetware, right? It's like having a 50,000-year-old MacBook. We don't do good with exponential stuff. And it has nothing to do with how smart someone is. It's just our brains aren't wired that way. But if you look back, it's easier for us to understand. And if you look back at just the state of the art a year ago and then 2 years ago, it should boggle your mind of how fast things are going. And again, I don't know where it's going to land. I mean, I have opinions like everyone else, but I know that I'd rather lean in than ignore it, right? So.
Right, right, right. Yeah. Well, yeah, this morning I was listening to Simon Willison and Swix actually having a conversation about, everything that happened in 2024. And it was taking me back. I'd forgotten about a lot of the AI, what are they, the tools like the Rabbit or whatever, the wearables.
Mhm.
I'd
Yeah,
completely forgotten about all of that. And
came
that
and
was
gone.
like the big thing. Yeah, exactly. Yeah, so I know it's happening. I try not to attend to the hype cycles too much. Obviously, here we are talking about messaging. These are foundational, important parts of computing, and yet the AI has thrown me into having to attend to things that happen for 2 weeks and then sort of flip away. Yeah, so it
Well, I
is.
mean, you can imagine a world, right, where you look at, hey, how do we get all the training data, you know, where we don't have to have these remote locations worrying about getting the training data to this model, right? We've had those use cases now for 3 years, 4 years with our customers. And then about 2 years ago, I shifted and I said, everything we talk about in terms of edge computing and location independence and M to N and data being able to be both synchronously replicated and asynchronously replicated, digital twins, downsampled mirrors, sources, we call them mux, demux sources. Um, if you look at inference, right, inference is going to, again, try to get closer and closer to you because people are just built like that. We want things faster and faster and faster. It's just and people go, explain to me what you mean. I said, imagine paying, in a restaurant with a credit card and it takes an hour to get processed. And they look at me like I've lost my mind. It's like, yeah, but I used to have to go into a bank, right, to get money. Yeah, it's the world keeps changing. But if you look at inference, right, there's a lot of complexity in there, but you can also kind of simplify it, which I try to do so I can understand things. There's a prompt augmentation, right? Which is you give me the prompt and I'm going to augment it with stuff, and I might need to access data sources through either RAG or in our world, just like, hey, Kate, just tell me whenever something changes and I'll hold on to it so I don't have to keep pounding on you when people are pounding on me asking questions. And so you can imagine that location independent M to N, don't need load balancers, any tricks to just figure out, where things are. Then of course there's the, hey, where's the model loaded? what's the most available GPU, what's closest to me, right? This notion of kind of almost like an arbitrage of getting to the model. But more importantly now, 2025 will be the agentic AI type of thing, which just means you're going to be walking through multiple agents and multiple models. And so you could imagine a world again where I'm in a vehicle and I'm asking, an LLM, OpenAI or Gemini or Anthropic's models for a plan, and that's running somewhere in the cloud on Big Iron. But then all of a sudden, it's a geo model that it says you need to talk to this, and that might be running on a cell tower. Then it says talk to the vision model, and that's running in the vehicle, right? So now you start to see where I'm not saying it's impossible, but it becomes very complex and brittle, which usually means security suffers when all of these moving parts have to fit together. And again, once people usually build these systems, it's kind of like the old databases. It's like, don't touch it. It's like, hey, can I access the database? No. You know what I mean? They become very brittle. And I don't think the world of these systems wants that. They want to be extremely dynamic and ebb and flow, both from where the services are, moving themselves around to where data is moving itself around just to adapt, right? These aren't static systems. And so we have a bunch of very, very large AI customers already. So it's very quiet. People don't know that we're powering so much of this stuff on a global stage, but we're learning a lot and it's exciting. And we can tell that the initial constructs of what we believe messaging brings, again, just changing the how, not necessarily the what, is extremely applicable today, both with edge and then AI inference is kind of a big one. Manufacturing as well. Manufacturing is going through a massive renaissance. And you're talking about Andy, I think about 3 years ago or so, we saw a lot of manufacturing customers coming on board and this whole, upper level, what I call information flow, but then they wanted the low level stuff as well. And so we built in direct MQTT connectivity into that. So you can just take an MQTT app that's running on a factory floor and just plug it straight in. So now all of a sudden you have all of the low factory level data plus the high level processing and decision making data flowing in the same systems. Most of our users and customers, after they've drank the Kool-Aid, if that's the right word, they kind of say you're like the central nervous system, right? It's not like, oh, there's the broker and I have to go to it. Kind of like Kafka is today. Kafka is
Hmm.
extremely powerful, but it's kind of like the old databases. There's some big thing over there that needs a perimeter security model and it's, needs 8 people to run it type stuff. We envision the world slightly differently. We do streaming for sure, but we envision it more of this Lego brick all of these topology servers together, and then it's just transparent. Wherever you are in the world, it just works.
Right. It uses Jetstream. Is that correct for streaming?
Jetstream is the persistence layer that we built in. Yeah.
I see. Okay.
Yeah.
All
So
right.
that started out as a fire and forget at most one system, which people always go, oh, wow, that's not very useful. And at least for me, I try to remind people that some of the most resilient systems I've ever built in my life that are still running 30 some years later were built on just at most once. You get yourself in trouble when you try to save and replay stuff.
Fair
But
enough.
that being said, that's kind of a natural consequence to what people want, right? But where I think Jetstream took off for us was is that we could think very differently about it because it was based on that connectivity layer. We had that for free, right? That location independent end-to-end, XYZ, no load balancers and all. And so we did 3 things with Jetstream that I think were compelling. One is synchronous and asynchronous replication are built in by default. So you can scale up an asset, you know what I mean? But you can also say, ooh, create a digital twin in a totally different cloud provider or in my factory and have them auto heal and sync and they're always up to date. And then the last, and by the way, the fact that the connectivity layer is a given for us is a demo we'll give is we'll set up a KV and somewhere in Europe. The guy, our DevRel guy, who was awesome, he still is awesome. He would run a little program that would be putting in and getting keys out of this KV. And so the KV, by the way, is we do materialized views over top of the core persistence technology. So we streaming like Kafka, but we also do object stores, so massive assets that are all flow controlled end to end. You can put them and pull them out, and then key values. And key values took off like gangbusters, which I'm really good friends with Salvatore, who wrote Redis, back in the day. Matter of fact, with VMware, I brought Salvatore to the United States for the first time, and I took him up to Twitter. So we got Twitter off of Memcache to Redis on that trip. And I said, no one would want to replace Redis. And I misunderstood what the ecosystem was struggling with. And so in this demo, right, we put it as an R1, one replica somewhere in Europe. And so it's like a 200 millisecond to get a value right out of it. And it's just printing it out and it's running in his home, right? And he goes, I didn't mean to put it in Amazon. I wanted to put it in Google. And in our world, that's literally one command and it instantaneously moves over. So it essentially stretches itself over and then it collapses itself down. And the whole time the app's just running. And you can see it. And it's like, oh, I didn't want it to be an R1. I want it to be an R3. And so we just scale up to an R3. Then we go into the asynchronous application. Go, oh, we need to have a mirror digital twin on the West Coast. And so we say create a mirror in Amazon, even though the origin's in Google in Europe. And all of a sudden his app just drops down to like 15 milliseconds or so response time, right? And it's still running. Then he goes, now I want to create one in my house on a Raspberry Pi. So he creates another mirror inside, another digital twin inside of his house. Next thing you know, it drops down to microseconds. And then we reverse it, and we tear all of it down. And so the app never got restarted, never got reconfigured. And so that notion of the world keeps changing and things are dynamic, and you want to keep optimizing for reducing latency when you access a service or data, that's kind of a core tenet to what we do. But when we show that demo, and by the way, the demo end to end is only about 4 minutes. And so when people see that, they're like, holy smokes, and so that time to value and things like that are a big thing for our customers. But again, you notice that we don't say pub sub, we don't say topics channels. It's kind of what it enables, not necessarily trying to change your brain to think about the way you would architect the system, right? Which is, oh, I need to talk to the Kate microservice and the Derek microservice, and we need this KV and this relational database or this object store, type stuff. Those are kind of the fundamental building blocks still of these systems, and we don't want to change that.
All right. And that makes a lot of sense. And I love how our conversation is just sort of organically branching out in ways that I couldn't even have anticipated. Although I knew we were going to talk about AI, I assumed it would be towards the end of our conversation. I love that we got it in so early. So, thank you for that. You anticipate me. But I do want to turn back the dial of time a little bit and talk about how you sort of ended up here. So, can we talk about TIBCO? To begin with, I'm so glad that you talked about some of the acquisitions, I guess, that happened, because I was kind of unclear about the timeline. Because my understanding was TIBCO was founded in 1997, but on Twitter you make it clear that you worked on TIBCO RV in the early 90s. So I was trying to figure that out. But it sounds like maybe that it, you started working on it maybe with your former employer that was then acquired. Is that accurate? Am I understanding that correctly?
So there was a famous investor out of Incline Village that funded Vivek, who was the CEO of TIBCO.
Okay.
And one of his rules was that every one of the companies he funded originally had to be called Technicron. So the company that I joined originally was called Technicron Software Systems, and they had a system called CI Server, and it was just barely starting to get into Wall Street. And they realized that they had something, but that they wanted to kind of do a redo, a modern version on it. And so when I got originally hired into Technicron, it was to port the CI server to the next step box. I was a big next step person. Steve Jobs' thing when he got kicked out of Apple. So when I did that, they go, ooh, you did that pretty quick. Maybe you want to sit with this team who are trying to think of the modern version. As we progressed on, what happened was is Technicron became TIBCO. So we didn't get bought or whatever. But then Vivek did a series of really interesting moves where we split the company and TIBCO Financial went to Reuters. Reuters bought that for all of the market feed data and market sheet and some of our projects there. And then TIBCO Software, which is the company that went public, maintained the low-level messaging stuff. Rendezvous, EMS hadn't been created yet. I designed that and I think post the IPO in 98, 97 maybe. And so believe it or not, it wasn't that TIBCO bought Technicron. It's just Technicron eventually morphed into it, and it just standed for the Information Bus Company. That's how we came up. And I did the original logo, believe it or not, which was kind of, yeah, crazy. Well, the web was so new back then, right? I mean, the web started in 94, 95. We used to have something called, it was an app that would show market data that wasn't ours that became real popular right before the internet started. And we were powering that. We powered a bunch of really interesting stuff. But TIBCO came out of Technicron and then it split. So he sold half of it to Reuters and then we took the other half public. And then, of course, after years and of course the big crash in 2000, which, we were not spared. It took us out pretty bad. We'd gone public in 97, I think. Yeah. And so they sold, into private. And then, of course, now I think they're bundled up with, is it Citrix? They're bundled with some company or whatever like that, the Silver Lake folks or the private equity folks and all. So,
Okay.
and another interesting story about TIBCO, at least in my opinion, was is that we knew we had a great thing, and hindsight's always 2020. And I was an engineer, right? I didn't have meaningful opinions on pricing and go-to-market strategies, and I just knew, ooh, we can solve that problem. So a lot of times they would bring me in on these big deals, like the FedEx deal was one of our largest. And I remember living in Memphis for 6 weeks, designing that system to scan all tracking data in FedEx. But I think TIBCO for a while got to a point where we should have adjusted to pricing pressure and we didn't. And we saw Wall Street react. So they reacted in two different ways. One was the AMQP protocol. So that was specifically designed to hedge against TIBCO because we were all closed source, right? This was before open source was really a big deal. And then, of course, JMS. So, and they're very, it sounds like you're like, why would you even put those in the same thing? But they were doing the exact same thing from a market perspective, just very, very different approaches. JMS was the API is consistent, the implementations can all be different, and EMS passed, all of the test suite stuff. And then the AMQP is the protocol is consistent, then you can build any type of client like Rabbit or whatever on top of it. But yeah, so AMQP exists because of TIBCO's, I believe, lack of awareness around, hey, we might want to lower prices. We just kept holding on, to these crazy high prices, which markets change and we probably should have adjusted. But again, I was just an engineer, so they might come out of the woodwork and say, no, that's not what happened. But I'm pretty sure that's why the Wall Street people got together and created AMQP.
Fair enough. Yeah, and you're again anticipating me because when we talk about your time at VMware and working on Cloud Foundry, I certainly want to talk about AMQP and Rabbit and all those things. But before we move on to that, can you talk to me at all about the rise of EAI? TIBCO was absolutely core to that movement. Where did this need arise from? And I'm interested in both your perspective as a technologist, an engineer working there, but also from an aspiring business perspective, right? I mean, now you're in that position where you're making these sort of pricing and go to market decisions.
Yeah, and yeah, I think we had two things going on. One is that information was being spread out from different systems, and people were the things that connected the systems. And people are fallible and they're expensive. And so you started seeing this notion of, hey, we should be able to automate getting data from SAP over to this system, blah, blah, blah. And yeah, I think TIBCO kind of built a lot of their early business on financial services, data dissemination, right? Stocks, then we started doing settlements, then we did, transactions, XYZ. But as we got to that point, we also realized we were kind of building a little closed system. You could write code to integrate other stuff, but we said they shouldn't have to write all this code. We should start integrating with all the other systems that we know are at Goldman and Lehman at the time before it went under. And so hats off to the leadership at TIBCO looking at that and going, hey, we need to double down. And they did start doing a lot of acquisitions then on pulling in technologies that could allow this EAI type of explosion. And now it's kind of table stakes. But even with Synadia, we've gotten to the point where internally I go, they're table stakes, but people don't value them. They value them, but not at a very high level, right? So in other words, they're not going to pay $100,000 for a connector to S3, right? But they want a connector to S3 and they want a connector to BigQuery and they want a connector to XYZ. And so once we felt we had MVP from a Synadia standpoint, now we've started that process about a year ago. And so we have a bunch of stuff that's about to come out there. And that's what I consider the transition from greenfield to brownfield opportunities with users and customers, right? So we can meet them closer to where they're at versus them having to, even though not change the what, they would have to rewrite a lot of stuff to change the how, right? To get everything running and flowing on the Synadia tech stack or the NATS code base. So
And so you were at TIBCO for 10 years,
12.
12, my goodness. Okay. So your LinkedIn is informing me you left in 2003. When you left, your job title was SVP and Chief Architect. So, you moved your way up. I'm just curious, what was it like working at TIBCO in the 90s?
It was an amazing time. I was very young and naive from a non-engineering standpoint. And so I believed in what we were doing. So I never sold a single share. So on paper, I went from looking really, really good to looking really, really bad. And at the time, it wasn't that you looked bad, it was real because they had weird tax rules and it was bad, right, in 2000. But the IPO was amazing. Being, in New York so much, I was on the first flight back in New York after 9/11, because I needed to get back there. The energy level of the financial systems, through the 90s was just bonkers. And it became a global thing, right? So we were Wall Street, but then obviously we did the Pit, the Chicago Mercantile. But then of course it was London and Tokyo, and then next thing you know, it was a global phenomenon. And so we went from T+3 settlement to T+1 while I was there. Now everything is pretty much real time. Everything's always running. And I think for me, it foreshadowed what other parts of society we're going to adapt, which is we're going to digitize everything, and the more data we can get, the better. And so, believe it or not, even though fin services is it's its own little bubble for sure, there's so many lessons learned coming out of that. The other one too is that what Synadia does, and other companies do this as well, but what Synadia does is critical infrastructure. If our stuff isn't working, you're not going to go take a coffee break and maybe you'll come back online in an hour type stuff. It's you're paging me, you know what I mean? And I get paged on every single production problem. And we learned that right at TIBCO. So TIBCO, I remember one time Vivek walked into my office and he had a suit. And I'm looking at it, I'm like, why do you have a suit? And he goes, because you're going to New York. I'm like, I live real close to the airport. He goes, no time. And I'm like, it's that bad. He goes, it's that bad. And so literally he handed me the suit. I grabbed my computer, and at the time, the laptops, you have to take like 18 batteries because they only lasted 5 minutes. Grab the CD with all the source code because no one had the source code, right? There was no GitHub, there was no anything like that. So grabbed the CD with all the modern, thing, burned a new one with what was on the top of, our, I think it was RCS at the time we were using, barely using any version control. And then literally went straight to SFO and went. So that energy level, and the stakes being so high, and the fact that, if things go down, it's really bad, I think kind of shaped what drives me. So I love the fact that Synadia stuff, all of our customers, the ones that are public, but even more the ones that we can't talk about yet, we are critical. If we stop working, their whole business stops. And that's both exciting and terrifying at the same time.
Oh man, I love that story. That's incredible. And it's hard, yeah, for someone who came up in the, I think 2018 was when I was a front end engineer. They, that just certainly wasn't my experience at all. So I love this. Can you talk to me about how the creative energy was as well? Because I mean, creating this messaging system was really a huge innovation. And so I'm wondering if, now we joke about having ping pong tables at tech firms, right? And making sure that the engineers feel like, they're able to have the sort of work-life balance that they've come to expect, right?
Yeah.
Was that part of it? Was it like Bell Labs? How did they make spark your creativity and make sure that you were creating really innovative things that needed to be built?
Yeah, I mean, I've reflected on that quite a bit. So obviously, I mean, I worked at Google, so I got the whole Google experience with
Yes,
Chef
yes, yes.
Charlie and the free meals and stuff. But TIBCO, we had an office, in on University Avenue in Palo Alto to start with. So that's kind of where I got introduced to California, was just walking up and down University, and I still love it. I still get nostalgic when I go back there. I'll stay right in town again. And I just walk back and forth just because. But then we moved to Porter Avenue, and we were right next to another startup called VMware, which was really funny at the time. But I think it was, we want people to innovate. You can fail, but fail fast and be accountable. The people that I worked with inspired me so much, but it was also that they put so much trust in me that allowed me, because again, I was at the time only 22 or so, and I'm getting yelled at by Lehman CTO on the trading floor, and then I'm up in the Nasdaq in Connecticut, going to FedEx and designing their system. So I think it was the trust that they put in me, and then the people, it was a very small group that was doing the messaging stuff early on. It got to be pretty big, and at one point I had 600 and some people reporting to me or whatever. I'm not a good manager, by the way, so that didn't work out well. And I was the first one to admit it. I mean, I told them, I'm like, I'm not good at this. Give me a clean sheet of paper, let me build something, give me a small group of people. But at the time, it was four of us starting Rendezvous. It was led by Denny Page, who's still in my mind. He taught me so much. But we ate lunch together every day. We'd go out somewhere, but as a group, I mean, we were just a tight. And this was, you couldn't work at home back in then, right?
Yeah.
There's barely dial up, you know what I mean? And so you had to be in the office and you had to be in that kind of space. But it was also an older, even the new buildings at Porter were more of an old style where you had an office and you could close your door. And so as I progressed through my career, I started to try to figure out when I was designing office space for Apsera, how do people work? And so I believe in person shared whiteboard when we're collaborating and trying to do the design, right? We're still like at a white sheet of paper. It's still hard to replace that. I mean, COVID led to an explosion of technologies that make it easier doing this remote, like Zoom and all that stuff. Shared whiteboards, Excalibur, which a lot of our team uses. But I still think getting in a room and co-designing. But then once you say, I know what we're going to do, then it's like, leave me alone. I'm going to go and I want to shut my door or I want to put my head down. And I think the TIBCO space, maybe not by design, but it just kind of worked that way. Google did something very similar, but they were very methodical about it. And I picked up on it as soon as I joined, which is we had our own offices, but only the CEO of Google, Eric, and then the guy that created Alta Vista had offices by themselves. Everyone else had to be paired up, including Larry and Sergey. They shared an office, but all of us faced away from each other. So if we were heads down and we put our headphones on or whatever, you could work. But then as you were moving throughout the campus, especially on your floor, all the kitchenettes and all the bathrooms were centrally located. So you were always crossing by other people. And I also noticed they moved us like every 6 weeks. Google did. And finally I was like, what are you guys doing? And they're like, oh, we do that on purpose because you get around different people. It makes you think differently. The fastest way to change the way you think is change your environment, right? Go for a walk, move somewhere or whatever. And so they would literally move us every 6 weeks. And so next thing you know, I was next to, the guys that created Cockroach DB. And then one time I was next to the guy that created Google Docs, Rightly, we acquired his company. And that was actually pretty smart, right? You think differently depending on who's around you and who you're interacting with. And so I believe deeply in that. But again, I think the ability to fail and the trust that they put in someone so young, that was pretty big deal. And by the way, we had one outage that it took me over 2 weeks to solve. I could not figure it out. And
Wow.
after about 3 days, they knew I was crispy already. So I would literally walk in, get a cup of coffee, go to my office, shut the door, and then at 9 o'clock at night, I would just leave and go home. I wouldn't do lunch. I mean, I was just so beside myself because they had put all that trust in me. And there was a bug, and they would only show up every once in a while. And it took me almost 2 weeks to find. But I remember I probably sounded like a young schoolgirl screaming out when I finally found it, but it took me almost 2 weeks to find it. And so I ran up to Denny, my boss's at the time's office. I said, I found it. And he goes, show me. You know what I mean? And so I was showing him, and I remember that day. He would check in and be like, he knew I was working on it. He knew that's all I was working on. And he's just like, how you doing? Do you need anything from me? You know what I mean? It wasn't like, what the hell are you doing? Get this thing fixed, X, Y, Z. And so that confidence and trust in me, I think, was the biggest dynamic.
That's amazing. And that's precisely the sort of insight that I was looking for. So I do think we've talked a little bit about Google. I would love to have you back on the show maybe to talk about this because again, I was a web developer. You were involved in some amazing projects there, but for the sake
Oh,
of
yeah.
trying to stick to our theme, why don't we skip ahead to VMware? We'll leave those 5 years for our next conversation. Talk to me about your time at VMware. So 2009, you became the CTO and chief architect for cloud application platforms at VMware, where you co-founded the cloud computing group and designed and architected Cloud Foundry. So hit me with how this ties into your time at TIBCO, the messaging initiatives you were involved in, and what that was like.
Yeah, so every system I had designed was based on a messaging construct. So like the FedEx system, the Wall Street systems, transportation and logistics, Intel fabs, that we ran at TIBCO, they were all based on this. And the only time I really got away from that was at Google. Google had their own version of papering over all the things. So instead of DNS, they had BNS, which would give you both a host and a port. And they had something called Stubby, right, which became gRPC way back in the day and the original protobufs type stuff. But the stuff that we did there, believe it or not, relatively speaking, it was the second most popular service for a while. Now, of course, we had just bought YouTube, and so YouTube obviously would kill it, and Google search was way up here. But we were doing between 60 and 100,000 queries a second. But it was a very small team. There was only really three of us, and then maybe a PM, which was our original PM was Brett Taylor, which that worked out really good for us. And he was a young, fresh out of Stanford graduate that Marissa said, "Hey, you need to meet this kid and bring him on." And I originally I could quickly tell that he was one of the smartest people I ever met. Anyway, we quickly realized that even though I don't know how long I was at Google, 8 years or so, 7, 8 years, something like that, we weren't going to be able to easily get out from underneath of this project because it was so popular. It was the beginning of the developer APIs. We called it the AJAX APIs. Then I created the JavaScript CDN, which I think they just shut down or something, but for a while that was really popular. And so Paul Moritz, who is mostly known in inner circles of, he's the one that really created the Windows dominance, right, at Microsoft. At Google, I worked with Mark Lakowski, who worked for him at Microsoft. And Paul was asked to take over for Diane Green at VMware. So Mark came to me one day and he goes, we're not going to be able to get out from underneath of this. My buddy just took over at VMware. We should go and talk to him. And I said, why would I ever go to VMware? It's like a virtualization company. I don't want to do any of that. But we got to sit down with Paul and Todd, the COO, who is also an ex-Microsoft guy. And I said, well, what would you want me to do? And they go, something cool that's not has to deal with hypervisors or virtualization. Just do something cool. And while at Google, I was noticing the birth of like Ruby on Rails and all this stuff where it was so easy to kind of play around and do these things on your laptop. But when you had to deploy to production, it was extremely painful. And so even at Google, I was started to become a really big fan of Heroku, which was, the early thing that was kind of the PaaS, right? Platform as a service. And so Paul was like, join us, just do something cool. So I had just a clean sheet of paper when I joined. But after about a week, I proposed to him and Todd and Steve Herrick, the CTO. They were the trifecta that I always talk with. I said, I want to do Heroku for the enterprise. That was it. That was my pitch. And they go, great. How long you need? And I said, I think I can have something workable in 3 months. And they go, great, knock yourself out. And so that's how it started. I just wanted to do Heroku for the enterprise. And at one point in time, we actually tried to buy Heroku because they said, great, you and another guy from Google, Vadim, who's awesome, Vadim Spivak's one of the best engineers I've ever met. And him and I tag teamed a lot at Google. He came over with myself and Mark as well to VMware. Paul and Todd goes, yeah, but it's only like, you two plus we got four other people around you now. How do we go faster? And I go, if you want to go faster, buy Heroku. And we had just signed a deal with Salesforce called VMforce, which was Cloud Foundry powering this PaaS for Salesforce. And we did the launch announcement and we did all kinds of stuff. And next thing you know, we're trying to potentially buy Heroku and it stalls, and they had asked me, what would you pay? And I told them, and then we were well past that already. And then they went quiet. And then about a week later, they came out and said, oh, Salesforce just bought us. And then we got the call that VMforce was dead. But I think PCF, Pivotal Cloud Foundry, is still a big moneymaker for VMware. At least that's what I heard. But that's where Nats was created, was around that. Because I said, ooh, I have to figure out how to build a system like I know how to build. I can't use TIBCO stuff. So I've looked at the open source stuff and it felt like RabbitMQ was the thing. And so I said, great, I'll just use RabbitMQ. And so I brought Alexis in. We bought his company. Alexis was kind of the head of that company that was driving Rabbit. But at a certain point, I could tell that Rabbit was an enterprise messaging system, more like a pet than cattle, right? You have to care for it and feed it. And if you didn't use it right, it would keep trying to do what you asked it to do, and then it would just lock up or whatever. And so about 2 weeks out from launch, we had a couple of issues, and it could have been me. I like simple things, and there's, because of the AMQP thing, and there's a lot of complexity that kind of percolates out into AMQP clients. So it could have been me, but I also realized I wanted something that was more like a utility that protected itself at all costs. So what I mean by that is let's say you and I live in the same building. I shouldn't be able to plug in a really bad blender and not only blow out all the electric in my unit, but take you out with it as well. And so a lot of these applications, and I put Rabbit in there, it's not as necessarily a fault. But when you look at these massively distributed systems with dynamic workloads, I need something that says, no, no, you're trying to do something wrong. I'll penalize you, but I'm not going to penalize Kate. Right. And so I kept saying that in my head. And I'm like, it seems to be that if I ask it to do something, it's going to try no matter what to do it, even at the detriment of everything else it's trying to use it at the time. And so, for the audience, what I'm talking about in these systems, again, it's not necessarily changing the what, just the how, but it's telemetry data, eventing, command and control. It's the normal stuff, right? We just use a messaging system to do all that versus disparate different types of technologies. And so we had a lockup, and I believe it was a Friday. It was a Friday morning, and it was like the third one. And again, it could have been me, you know what I mean? But I said, enough's enough. And I just stormed out and I left. And Vadim's like, "Where are you going?" I said, "I'll be back on Monday." I said, "I'm tired of this, blah, blah, blah." I was a lot younger then, you know what I mean? It takes a lot to get me upset, but I was bugged. And so I'm like, I know what I want the system to do, the messaging system. I know what I don't want it to do. And I know that I want it to protect itself at all costs, meaning I can't do something silly and take it out for, the detriment of you. And so we were building Cloud Foundry in Ruby. Remember the Ruby on Rails thing, what I was watching. And so I said, I think I can build this in a weekend. And everyone says that, and you usually can't. But I did. So I built it in a weekend, came in on Monday, ripped RabbitMQ out, put Nats in. That freaked out a lot of people. So I got called to the principal's office for that one. I also made them make it MIT. So it was the first open source. Cloud Foundry was also going to be the first open source project from VMware. That was a big, huge deal.
Oh, I didn't realize.
But technically, Nats was first, and I made them open source that one too with MIT. And they fought me. They didn't think it was a good decision. And Alexis was upset at me, but we're very close now again. But yeah, and so it took off. And then when I left VMware, I wanted to create a better version of Cloud Foundry, one that had more security, governance, could stretch more, do some other things. And then the decision-making process for that company was, do we want to go with not Ruby, although I love Ruby and I love Mats. It's just not a good deployment language in my opinion. Do we want to go with Node.js or do we want to go with Go, this brand new language coming out of Google? And so we picked Go. And so the modern version of Nats is all Go.
That is exactly the history that I was interested in hearing about. I didn't realize that you had built that first version of Nats, and was it in a one weekend? I mean, that's incredible.
Well, I went home and I was really ticked off. And so I sat down and I've done these before, obviously. So the first thing I did was put the connection logic together. Then I did the subject router, right? How you route things and things like that. And so in Ruby, I was pretty proficient. We were doing a lot of code in there at the time. Traditionally, I'm a C programmer. I don't think I can program in C anymore. I'm too old. I don't have enough time left. But yeah, so yeah, it was not as hard as you think. And again, the only things it did was route messages. It did what's called distributed queuing, which is that load balancer replacement. So there can be 100 Kates, and I'm going to randomly select one of you. The modern version of Nats also is geo-aware. So the very first version of Nats at VMware was a single server, right? I didn't design any clustering or security or none of that stuff. But the modern version, because you can Lego brick these servers together in any topology you want. The distributed queuing, which says, hey, I want to ask a question of Kate, and there's 1,000 of them, just find the best one for me, is geo-aware in the modern version. So if there's one that's very close to me, I'll prefer that one. And if there's not, I just keep watching and I know how far all of the other servers are away internally, not your app. Your app doesn't have to worry about this. The NAT system and Synadia's tech handles all this. And so it had that and it had a circuit breaker pattern. So the other one that I cared deeply about was asking a question of an unknown set of respondents, and I only want the best answer. And you can qualify what the best answer is, but in this case, who was the first person to respond? So you can imagine a world where traditional messaging technologies, you would run this thing and send out a request and you get a response back, but you're like, why did my CPU spike? Why did my memory spike? And it's because all 10,000 responses were coming at you and you just had to throw them away, right? And so the other thing that the original version of Nats had was I want to ask a question and I only want one response, and it would circuit break all through the system. So as soon as one response was flowing towards me, it chopped all the other ones off. And so my client application didn't have to process and throw away all of these responses. And that's all it had, the original one. It was just fire and forget, obviously subject-based routing, the normal wildcard type stuff. Slow consumers, if you're a slow consumer, it's kind of like plugging the blender into the electric socket. We just chop you off. We just cut you off. And we're like, nope, you're not a good citizen. And then the DQ. And that was it. That's all that existed. And we could build all of Cloud Foundry with that, including it had a really interesting scheduling algorithm that wasn't a command and control centralized thing. It was any number of people can be asking for help to run jobs in these DEAs. Droplet execution agents is what we call them. Me and Vadim named those at like 2 a.m. in the morning. Never let engineers name stuff. It's so bad. And so yeah, and that's where it is. Now, of course, the modern version of that has a lot of stuff. And of course, Jetstream is a massive component that draws
Yeah.
a lot of attention. But yeah, that's how it all started. And it's still on GitHub. So the very first commits are still in the same history buffer. So you can go back and look at the Ruby when I used regular expressions for the subject router, which is goofball because it's slower in Christmas to do it that way. But I had to have something working.
That's tremendous. I mean, speaking of naming, so you walk into the office on Monday, you've got your GitHub repo of Nats. Was it named Nats from the beginning? And on the record, what does Nats stand for?
Yeah. So the marketing team has one version of it, but I think it's already
Ah,
been put out on, I think it was on Hacker News and someone else posted it. It stood for not another TIBCO server. Yeah.
wonderful. Okay. Yes, I alluded to it in my post, but I didn't know where you stood on this. So thank you for clarifying.
No, I'm being honest. That's exactly what, but the marketing team, I remember go, oh crap, we can't say that. Let's call it a neural autonomic transport system or something like that. So you'll see
That's
that.
it. Yep.
But if I'm being honest, and because I said on my way home, I'm driving home and I'm agitated. I'm like, I don't want to build another TIBCO server. I don't want to build another TIBCO server. And so by the time I got home, I had already had the name. Naming and caching validation are hardest things in computer science. So I already had the name.
I love that. So the name came first. Okay, so let's dig into Nats a little bit because I'm interested in the open source story as well. So what is your sort of position on open source? You mentioned the MIT license. Open protocols are such a big part of messaging from the beginning. Like, what is your philosophy around open source?
Wow, we need probably another 2 hours.
I know, I know. If you
You
can't
know, I
condense it,
think
we can put a pin in it, but I am
yeah,
curious.
I have a lot of opinions on open source. I think in general, it's a massive net positive.
Okay.
And I went through closed source to open source, then all of the licenses in open source from GPL to LGPL to MIT at the other end of the spectrum and everything in between. I've went through foundations, probably an unpopular opinion, but I don't know if the story's been fully written on if foundations are a net positive or not. That's my personal opinion.
Okay.
I believe that that OSS is at a very critical time right now. And what I mean by that is that a lot of it, not all, but a lot of innovation still comes from very small groups, either inside larger companies or startups that are trying to do something right with open source and trying to make a business out of it. And I think that the ecosystem is not aligned with that. I think what the ecosystem is aligned with is massive initiatives by the hyperscalers that drive a consumer bias to zero. And if you drive the consumer bias to zero, meaning that the consumer thinks that they're entitled to it being free, that they never have to pay, that causes a lot of pain. Charity, by the way, is not a business model, in my opinion. And so what we're seeing is I when we started Synadia, I said, well, edge is going to be a thing. And I made a tweet years ago that I thought it would dwarf cloud, by orders of magnitude very, very quickly. And I still believe on that, right? I also believe that since we are so critical, that any company that was running us a production would want to have a commercial relationship with us and have support. What I didn't foresee is, and again, if you're like a little startup and you don't have enough money to pay, but you're trying to give back in other reasons, I'm fine with all that, right? But in terms of Synadia as a commercial viable entity, I'm like, hey, if you use it and you value it, you should have a commercial agreement with us. And I remember starting the company, what, 7 years ago, almost eight now, right? The end of December of 2017, and saying, oh yeah, we're so critical, they'll have to have, a relationship with us. And what I've seen over the last 5 years is that trend is reversing. So Fortune 100 companies go, if it's open source, we're not paying you squat. And what happens there is that, and this is where I call it the big incentive misalignment, right? They will call us if there's a problem. On our side, we're trying to make software that doesn't have problems and trying to make perfect docs and reference architectures. So our incentive is to do this, but at the detriment of us as a commercial entity, right? Because if these big companies, and you'll know all these companies' names, that they just say, nope, we're not paying you. But if we made it harder, right, to deploy our stuff, or we had bugs, or there was tricks that you needed to talk to us, or XYZ, or the docs weren't clear enough about how to do something, that's an incentive misalignment where people now will pay you to solve that problem, and that's not what I think is correct. And so, in a nutshell, I do believe it's a net positive across the deal. I think not always, but mostly hyperscalers that don't need to make money off of this, that use it for other reasons, like Kubernetes as greasing the skids to allow workload transportability into Google Cloud from Amazon or Azure. They had a side effect of driving consumer bias to zero. I mean, to date, we've probably invested 40 plus $1 million into the NATS technology. And we have people on GitHub that they're not trying to do it, but you can tell they're so entitled. They're like, you need to do this for me. And it's like, what do you mean I need to do this for you? It's like, and so now I just say, ooh, I said, we love our ecosystem and we do, and we want to help out. Are you a Synadia customer? And they always go, no, why? And I go, because we prioritize people that pay us and want to ensure our survival, meaning the project survival and the tech survival. And so I think it's kind of not at a crossroads yet, but I bet you it's becoming pretty close. And you're seeing a lot more companies switch licenses or doing other things to try to say, hey, you should pay us, even if it's only for a certain period of time, and then everything reverts back to totally open source. And so I don't know where the path is going, but I know that I don't feel good saying if we make crappier software, it'll help us as a business entity. That doesn't feel good. All right, so we got to figure that one out. And there's a lot of companies that, are just awesome. They're like, absolutely, we're going to have a commercial agreement with you. But there's a alarmingly increasing number of Fortune, 500, Global 1000 companies that go, oh, yeah, our policies, we just don't pay if it's open source.
Right. And I think maybe it would be worth stating explicitly what is the relationship between NATS and Synadia?
So Synadia houses almost all the maintainers, right? And so I would say 99% of the server code base is all from VMware, the people that were at VMware, but mostly me. I think I'm 98% of everything from VMware, then Apcera, then Synadia. So we're the main maintainers, right? And so, and we wanted to make a commercially viable, business out of intelligent data flow and intelligent connectivity for these modern distributed systems that cross geos, cloud providers out to edge. That was kind of our initial game plan 7 years or 8 years ago when we started.
All right. And so you mentioned, knowing in what would that have been 2009 when you created NATS? Was it that first year?
2010, I think, is when
2010.
I
Okay,
first
so the year
created. I
after that.
think I'd have to look up the GitHub, but it's on there. It's the stamp's on there.
That's fine.
It's October, I think, 2010. Yeah,
Okay. And so and for that one, you knew that you wanted an MIT license. Is it still an MIT license?
it's Apache 2 because it's part of the CNCF. So one of the
Oh, very
rules
good.
becoming part of the CNCF, it's Apache 2, which is still very liberal. It has a little bit of protections, mostly for the project maintainers, which is good. So yeah, it's Apache 2 right now.
Okay. And so did you consider creating a NATS foundation? How did you get hooked up with the CNCF?
I was part of the original founding governing board for the CNCF. The original
Wow.
kickoff meeting at the Las Vegas data center I was at, and I believed in what they were trying to do. But again, it was very early. The only other foundation was kind of the Apache 2, and the Linux Foundation was there, and they were trying to create this, cloud native compute foundation, obviously. And I like this notion of two things. So in TIBCO, we had to do a lot of awareness and a lot of education. So we spent a lot of time educating customers of what problems they had and the marketing stuff. And so when we started Synadia, I was like, I don't want to have to swim upstream. And so our bet is that Edge was going to force people into going, oh crap, that stuff that worked in the cloud, it's not working over here. We have to look for alternative ways to accomplish what we're doing. And then the CNCF was this could help us with our awareness issue. So we don't have to spend all these marketing dollars and try to get the awareness out. And early on, it did that quite well. Where I think the CNCF has gone, I don't, and again, this is just my opinion, but I don't know if there's that crystal clear, clear as a bell advantage as a user looking at a CNCF landscape. I don't think you look at that and go, oh, I know exactly what to do. I mean, here's the problem I have. Oh yeah, it's like an eye chart. You're just looking at this thing. So I'm like, how's the CNCF serving the end users, and then how's it serving the projects? And within the project realm, I think it serves projects that have lots of big companies participating well. I don't know if the match is as well suited yet for companies that are trying to make a business out of the open source project, right? And they have most of the maintainers, right? Because the CNCF has slowly morphed into, oh, you have to have lots of people contributing to a project for it to be viable, to be graduated. And, I don't think that's applicable for all projects. I'm not saying it's not applicable to some, but I don't think it's a blanket rule. And I remember being challenged a couple of years ago within one of the meetings and said, well, you know, you have to take our word for it. This is better. I'm like, that's totally fair. But I said, remember, I'm kind of an old dude. And I said, I have three projects now that are still running over 30 years. There's one over 20 and there's two over 10. So I think I kind of know how to create something that lasts, a long time, right? Because they're like, hey, how do we know that it's going to last so that the users can bet on it? And And I totally get that. That's totally legit. But I think the way the criteria of way they're judging it um, as a blanket rule might not be the correct way for all projects, if that makes sense.
Yeah, absolutely. Fair enough. So, was this the first foundation that you were involved with?
Well, the JMS kind of had its own bunch of companies that were ratifying it, and then Microsoft pulled me into that WS Star debacle back in the day that also had some sort of like makeshift, I mean, early version. So not as much like the Apache stuff, but it did have like lots of companies and the more the merrier type stuff.
Right, right. So
But
you've seen some
officially, yeah,
things.
I've
Yeah.
seen some things.
Okay.
Yeah, yeah. And again, it might be, most people in the audience might disagree, but I don't know if we really understand if foundations drive value into the ecosystem, right? And again, I'm not saying it doesn't. I'm just saying for me personally, I don't know the answer to that yet. It's still kind of a work in progress to me.
Well, I think it's such an important conversation to have, not only just for the tech industry writ large, but also when we talk about messaging, because open protocols are such an important part of that story, especially when you look at like the financial industry and how everybody was trying to make sure that they could communicate across these different systems and everyone kind of had to play nice together. And so I think that there's a story to tell about collaboration and making sure that, sure, we're competing, we're all trying to, make sure we get the biggest
Yeah,
slice of this pie, but at the same time, it's about communication. That's what messaging is, right? We got to communicate.
it definitely is. Although, again, I'm not sure that, all the protocol stuff actually bears out what people think it does. Now,
Ooh,
HTTP does, and I agree with communication, but you can imagine a world where, let's say there's a NAT system, right? And by the way, I modeled the protocol based on Redis. I had already decided to pull Redis into Cloud Foundry as one of the things it was going to have and XYZ. And so I was talking to Salvatore a lot. And, I was like, oh, I've only done binary protocols. And he's like, oh, yeah, the tech stuff. And I'm like, I can probably make it super fast. And I said, why did you do it that way? And he said, so that it would be easy for people to write clients in any language they wanted to. I was like, oh, that's smart. So he goes, otherwise we have to write all of them. But if you make the protocol really simple, XYZ. And obviously Redis's protocol is not formalized, but almost every WAF and firewall understands it. It's incredibly popular. Um, and so if you have a world where it's easily accessible, but then the last mile endpoints can be HTTP, MQTT, I probably won't do AMQP just for, historical reasons. It's a very complicated protocol, unnecessarily so, in my opinion. I think that it could help, but I have no desire to try to go like to Oasis or something like that and try to standardize the NATS protocol. We've standardized the ports, so they're in listings and stuff, and we care deeply that the machinery that a lot of security groups use is aware of our protocol, but it's a text-based protocol, so it's literally like an hour's worth of work. I mean, it's drop dead simple to build a protocol aware version of a security device that understands NATs. So it's actually it's as simple, I think, as HTTPs. It's actually simpler than HTTP as a
huh.
protocol. Yeah.
Okay.
And it's just
Yeah.
text-based. So you can actually telnet to a server and go back and forth and you can see how the whole thing works. And so one of our early demos was to, if people who cared wanted to see how it works underneath the covers, like watch the protocol, you can actually just telnet and type to a server and see what it's doing.
All
Yeah.
right. Yeah. No, I like it
And
because it.
I did go through Oasis a couple times, the W3C and yeah, they're painful. They definitely have their place, don't get me wrong. But I don't think us not being standardized on something. And people said, why didn't you standardize on HTTP? And I'm like, we were trying to do everything different than HTTP when HTTP was just one-to-one synchronous request reply. Because everyone's like, gRPC is based on HTTP and HTTP3. And I'm like, yeah, we predated all of that stuff.
All right. No, this is great. I love when these conversations become a little spicy. It's good. The more opinions, the better. This is, we're not here to be
Well,
wishy
the
washy. This
opinions
is it.
opinions are interesting, right? Because they're free, meaning you can throw it away. You don't have to take what I say, and you can just discard it, which is good.
Yeah. That's amazing. Yeah, no, thank you. Okay, so I got one last question, then I think we will wrap up here. So, so I think arguably we're in what many would consider the Kafka era of streaming, right? So, what is your take on the future of streaming? Do you feel like we truly are in the Kafka era? Are we? How is this sort of molding where messaging is going to be going in the next 5 to 10 years?
I think streaming and event sourcing are incredibly powerful constructs, right? And I think Kafka is the de facto 800-pound gorilla. Where I think a lot of our customers come to us is it's this big thing like the old databases, like the Oracle databases. It sits in some data center in one region and it takes a whole bunch of people and a whole bunch of money to run it. And also, I think that event sourcing and streaming are becoming a more critical component to architectures, but they're not the only one. And so what my career, or at least I've experienced in my career, is we go through waves. And I think I'm on my fourth one. And the wave goes something like this. When it's on its upswing, it's I want more options. I want more tools in the toolbox. Give me more stuff, more stuff, more stuff. And then we reach a saturation point, right, as an ecosystem. And then we immediately go into a deep dive of this is too complex. There's too many moving parts. I want to, reduce the surface area. We're definitely in a down deal. And so a lot of customers are coming to us and they're like, we've got HTTP, we've got service mesh and API gateways and gRPC, and then we've got Kafka, and then we've got Redis, and then we've got, a relational database, let's say Cockroach or whatever. And they're like, how do we reduce this complexity and be able to take this thing and then move it so it runs inside of a vehicle or runs in a cafe or runs in a distribution center or a factory? That's kind of where we hit our stride. So we definitely do streaming. I don't know if we're going to be doing exabytes like Kafka does today, although we have plans for that. But for very high speed, real time streaming, eventing, plus work queues, plus key value stores, plus object stores, plus normal request reply, which you shouldn't be storing stuff in memory or on disk for request reply. It's kind of like when Kafka did a push and said, we're good for microservices. And I said, that's like Google writing all their log lines before they return your search result. That just will never happen. I think that the world is a lot bigger, and that if there's a tech stack that doesn't fulfill everything, but kind of gives you that reduction in surface area and you can check off a lot of things with one tech stack, I think that's kind of the future. And I think Kafka will continue to probably push into adjacent markets, right? Because they're a Confluent, at least because they're a public company. And by the way, I hope I have their level of success. Don't get me wrong, but I think they're going to struggle to keep trying different adjacent markets where they're not built for that. They're purposely built for very, very one specific use case, and they do it really, really well. But modern systems have, lots of different moving parts. And so what we're trying to capture is the edge, transfer to edge. The majority of interactions will be out there. The rules are very different than in the cloud. Perimeter-based security models don't really exist out there. And so we don't depend on those. We don't depend on DNS. You can run these things, just say run it. You don't have to have like a PhD in how to run a Kafka broker cluster type stuff. So we like our positioning, but we work really well with Kafka. So we'll do like a lot of the edge locations and funnel in XYZ. We do have some customers that, after a couple of years, they get so comfortable with our tech that they replace everything with us. But we still have some customers that say, no, we want you to interoperate with this big Kafka cluster running on, you know, in Oregon or something like that. And of course, that's what we'll do.
Wonderful. And I think that's a really good final topic for us to deal with because, yeah, I think that the world is bigger than Kafka. They take up a lot of oxygen in the room, but, there's still a lot out there, and the story of messaging is still, evolving and being written.
It is. It
Before
is.
Absolutely. So before we go, for folks who are interested in keeping up with more of your thoughts on all of these subjects, we've mentioned that you participate on Twitter or X, if you prefer. Are there other social channels that you participate in?
Just LinkedIn again, I'm old enough that I just use my name. So it's just Derek Collison. You know what I mean? I don't have a fancy name and it's hard to find me. Yeah, if you want to find me, it's really easy. I try to be accessible. We have an open Slack for Nats, which is I think I don't know how many, 10,000 more people or so. And then you could just email me, Derek at nats.io or Derek at synadia.com. And I try to respond to everybody that emails. So be happy to hear from anybody, especially with questions and stuff like that. So, and Kate, thank you for having me on. I really appreciate it. I don't know if I lived up to any of the Forrest Gump type of stuff, but um, I
No,
think a
absolutely.
lot of us in the this ecosystem have a lot of really interesting stories, including your previous guests. It's just some amazing stuff of going through, and there's even more stories over a cup of coffee or a glass of wine or something type deals that
Yeah.
I'm sure they have and I have that are just bonkers. But yeah,
Yeah.
really, really
Yeah,
cool.
I've heard a few. But yeah, I know I appreciate that. And thank you so much for coming on. Again, my name is Kate Holterhoff, Senior Analyst at RedMonk. If you enjoyed this conversation, please like, subscribe, and review the Monkcast on your podcast platform of choice. If you are watching us on RedMonk's YouTube channel, please like, subscribe, and engage with us in the comments.